Welcome back to War Machines Chronicles. Today, we're diving into a story of genius, fear, and unimaginable power, the invention of the atomic bomb. This isn't just a tale of a weapon, but a journey that changed the course of human history forever. How did humanity unlock the power of the atom, and what did it cost us? The story doesn't start in a secret lab during a war, but much earlier, in the quiet world of physics. It all began in 1896 when Henri Becquerel accidentally discovered radioactivity. Soon after, Marie and Pierre Curie isolated new radioactive elements like polonium and radium, opening a door to a new, unseen world. Then, in 1905, a young Albert Einstein published his revolutionary equation, E=mc2. It was just a theory on paper, but it held a mind-blowing secret. Mass could be converted into a colossal amount of energy. For decades, this was purely science. But in 1938, in Germany, Otto Hahn and Fritz Strassmann made a startling discovery. They split a uranium atom. Lise Meitner and Otto Frisch, exiled from Nazi Germany, quickly explained what had happened: nuclear fission. When the atom split, it released a burst of energy. Suddenly, Einstein's equation wasn't just a theory anymore. The idea was born. If you could create a chain reaction of splitting atoms, you could unleash an energy explosion beyond anything ever witnessed. As World War II engulfed the globe, this idea turned from a scientific curiosity into a terrifying possibility. The world's top physicists, many of whom had fled Europe, feared that Nazi Germany was already working on an atomic weapon. In 1939, a concerned Leo Szilard convinced Albert Einstein to sign a letter to U.S. President Franklin D. Roosevelt, warning him of the danger. The message was clear: America had to build the bomb before the Nazis did. Roosevelt listened, and so began one of the most secret and ambitious undertakings in history, the Manhattan Project. Launched in 1942, this wasn't just a small research group. It was a massive industrial and scientific enterprise, employing over 130,000 people, and costing about $2 billion at the time, an astronomical sum. The project was led by two key figures. The military commander was General Leslie Groves, a no-nonsense engineer known for his efficiency. The scientific director was J. Robert Oppenheimer, a brilliant but complex theoretical physicist. Under his leadership, the brightest minds in science gathered in a secret city built from scratch in the middle of nowhere, Los Alamos, New Mexico. This was the brain of the operation. But the body was spread across the country. In Oak Ridge, Tennessee, huge factories worked tirelessly to enrich uranium. In Hanford, Washington, massive reactors were built to produce a brand new element, plutonium. The scale was unprecedented, and the goal was singular: to build a functional atomic weapon. The scientists at Los Alamos worked on two different designs. The first was a gun-type bomb, relatively simple in concept. The second design was far more complex. It used plutonium-239 and required a method called implosion. A sphere of plutonium had to be perfectly compressed by conventional explosives to trigger the nuclear chain reaction. It was an immense engineering challenge. This bomb would be called Fat Man. By the summer of 1945, the plutonium bomb was ready for a test. On July 16th, in a remote desert area of New Mexico called Alamogordo, the world's first nuclear device, codenamed Trinity, was detonated. The result was beyond anything they had imagined. A flash brighter than 1,000 suns lit up the pre-dawn sky, followed by a deafening roar and a terrifying mushroom cloud rising miles into the atmosphere. The explosion was equivalent to 20,000 tons of TNT. The test was a success, but it left the creators in a state of awe and terror. As he witnessed the blast, Oppenheimer recalled a line from the Hindu scripture, the Bhagavad Gita: "Now I am become death, the destroyer of worlds." The atomic age had begun. By this time, Germany had already surrendered. But the war in the Pacific was still raging. President Harry Truman, who took office after Roosevelt's death, now faced a monumental decision. Should he use this new superweapon against Japan to force a surrender and avoid a costly invasion? The decision was made. On August 6, 1945, a B-29 bomber named the Enola Gay dropped Little Boy on the city of Hiroshima. The bomb detonated with the force of 15,000 tons of TNT. In an instant, the city center was vaporized. An estimated 70,000 people died immediately, with tens of thousands more succumbing to injuries and radiation sickness in the following months. Despite the devastation, Japan did not surrender. 3 days later, on August 9th, a second bomb, Fat Man, was dropped on the city of Nagasaki. The explosion, even more powerful than Hiroshima's, killed around 70,000 people. 6 days after the bombing of Nagasaki, Emperor Hirohito announced Japan's unconditional surrender, officially ending World War II. The use of the bombs ended the war, but it also unleashed a new kind of fear upon the world. The post-1945 era was defined by the atom. In 1949, the Soviet Union shocked the West by testing its own atomic bomb, starting a terrifying nuclear arms race. Soon, the United Kingdom, France, and China joined the nuclear club. This led to the Cold War, a period dominated by the principle of mutually assured destruction, or MAD. The chilling logic was that if either the US or the USSR launched a nuclear attack, the other would retaliate, leading to the complete annihilation of both nations, and possibly the world. For decades, humanity lived under the shadow of a potential nuclear holocaust. To prevent this apocalypse, international efforts began to control the spread and use of nuclear weapons. Treaties like the Nuclear Non-Proliferation Treaty of 1968 aimed to stop more countries from acquiring bombs, while arms reduction treaties like START worked to reduce the massive arsenals of the superpowers. The legacy of the atomic bomb is deeply dualistic. The same nuclear physics that gave us the bomb also gave us peaceful applications. Nuclear energy now powers cities around the world. Nuclear medicine, like radiotherapy, saves lives every day. But this progress cannot erase the irreversible damage. The radiation from the bombs caused genetic diseases that affected generations. The trauma inflicted upon the survivors and the devastation of the cities serve as a permanent reminder of the weapon's horror. The atomic bomb represents one of humanity's greatest scientific achievements and, simultaneously, one of its most terrifying creations. It is a powerful symbol of the eternal dilemma we face between the pursuit of knowledge and our moral responsibility. In creating the bomb, we learned that we now possess the power to destroy ourselves. The challenge for every generation since has been to ensure that we never, ever use it again. Thanks for joining us on War Machines Chronicles. If you found this history as fascinating as we did, don't forget to like, subscribe, and hit the bell icon so you do not miss our next deep dive into the machines and stories that have shaped our world. See you next time.